Now, under the properties of indices, we have four properties. So the first property I call the negative powers. Now let's look at the negative powers. Given that a exponent 3 divided by a exponent 5, from what we know under division of indices, a exponent 3 divided by a exponent 5 is the same as a exponent 3 over a exponent 5. Also the same as a 3 minus 5. Also the same as a negative 2. Now we want to write this thing as a fraction whose exponent is positive. Now let's come back to this spot. We'll soon come here. Let's come back to this spot again. Given a exponent 3 over a exponent 5, this thing means that we write a 3 times. A has reflected 3 times because of the exponent 3. The a here has also reflected 5 times. So we have 1, 2, 3, 4, 5. So let's cancel out. 1, a cancels a cancels a. So you see, we left it 1 times 1 times 1. You can't just say that a cancels a, so it's 0. No. It's just the same as you cancelling, let's say, 2 over 2. When you cancel 2 divided by 2 is 1. When two people share 2 items, each person gets 1. So you can't just leave it like that. So a cancels a cancels a cancels a. So you'll be left with 1 on top. And you have a by a. And how many a's do we have here? We have 2 a's. Now because this thing, this procedure and this procedure is true, then climbing back to this answer, this answer is a exponent negative 2, which is what we had from this problem, and this is what we had from this problem. Now because the 2 steps led us to these 2 answers, then we can say that a exponent negative 2 is the same as 1 over a squared. So when you have any negative index, you can write it as a fraction. On that note, if you are given, let's say, m exponent negative 4, you can write it as 1 over m4. If you are given, let's say, p exponent negative 3, that can write as 1 over p exponent 3. Now let's climb up a little bit with this example. Let's say I have 2a exponent negative 4. 2a exponent negative 4 means that 2 times a exponent negative 4. So this thing can be written as 2 times 1 over a4. 2 multiplied by 1 is 2 all over a exponent 4. So when you have a number multiplying a variable with a negative index, quickly you can do it, the number over the variable to the same exponent, but this time around is going to be positive. So let's look at this one too. Let's assume I have, let's say, 5x negative 6. 5x negative 6 is the same as 5 over x exponent 6. That's what you are saying. So this is what happens when you have negative powers. So let's look at this example. Let's say I have 3 exponent negative 3. 3 exponent negative 3 is the same as 1 over 3 cubed. And 1 over 3 cubed is 1 over 27. Another example we can think of is, let's say, 2 exponent negative 5. That's 1 over 2 exponent 5 and 1 over 32. Because 2 exponent 5 is 2 multiplying itself 5 times. So this is what you get, and this is what you get for this problem. The last thing we can consider, let's look at this last example. Let's say I have a negative 2, have x negative 3 and have y squared. Now this thing we see here can be written as 1 over a squared multiplying 1 over x cubed multiplying y squared. Now because this thing is negated, that's why we wrote it as this. This is negated, that's why but this 2 here is not negated, so we keep it as it is. So every whole number is over 1. 1 times y squared, you get y squared. A squared times s cubed times 1, you get a squared s cubed. And you rest here because this is how far you can go. Now the next property I call the power of 0 or zero index. Now the theorem says that if you have any number exponent, let's say a number a exponent 5 divided by another number exponent 5, that's a5 a5. Now a5 is the same as a multiplied by a multiplied by a multiplied by a. You have 1 2 3 4 and the last a. The same thing happens here. Now you can see that we have 5 a's here, we have 5 a's here. 1 2 3 4 1 2. So we have 5 a's here. So you can see that all has cancelled out and we get 1 over 1, and the answer is 1. On that note, what we're trying to say is that if you have a exponent 5 divided by another a exponent 5, which is the same as a5 minus 5, get a0. If this is what is happening, this problem led us to 1. Then we can also say that obviously this one to give you 1. So what we usually say is that any non-zero number raised to the power 0 is 1. Any non-zero number raised to the power 0 is 1. If the number is not 0, if the base is not 0, and you are having an exponent of 0, the result should be 1. So from this evidence, we had 1, which means when I have xm divided by xm, the answer to this problem is 1. The base are the same, the exponent are the same, so we get 1. So let's look at this example. If we have 2 3 divided by another 2 3, so because of what happened, we'll get 1 at the end of the day. Now let's look at this one too. Let's look at this case. Let's say I have 2 over 3 with an index of 0. So if you have 2 over 3 with an index of 0, let's see whether we get 1 now. Now this 0 here influence this, and this 0 here has an influence on this. But because of what this young man said, he said that any number that is not 0, who is having an exponent of 0, is 1. Then 2 0 becomes 1, 3 0 becomes 1. So this one too gives us 1. So on that note, we can also say that if you have a on b with an exponent of 0, you must get 1. That's what we can also say. If you have any fraction with an exponent of 0, then you must get 1. And you have any number with an exponent of 0, you must get 1. Now let's look for negative numbers. Let's say if I have negative a exponent 0, negative a exponent 0, negative a exponent 0 is the same as negative here, and keep a exponent 0 in bracket. So you have negative here, a0 is 1, the negative affect this, you get negative 1. So if the number is negated and it's having an exponent of 0, you will get negative 1. Let's consider huge numbers. let's say 1 2 4 5 exponent 0 is 1. Let's say 99999, whatever the number is, exponent 0 is 1. So for us, it's having an exponent of 0. The answer is 1. Now the property 3, I call the square root cases. Let's look at case 1. From our calculators, or from what we know, the square root of 9 is 3. Now let's look at how indices understands root 9. Indices says that root of 9 is the same as 9 raised to the power 1 over 2. Indices again say that this 9 here can be expressed in terms of 3. So indices express 9 as 3 squared. Indices said that these 2 here can be multiplied to the exponent 1 over 2. And when you multiply 2 by 1 over 2, these 2 cancels that. You'll be left with 3 exponent 1, which is 3. So from what we've seen so far, the theorem is saying that root of any number a is the same as the number exponent half. Another theorem is saying that, then let's look at this one too. The cube root of, let's say, 8 is 2 from calculators. Let's classify this as well. The cube root of 8 is 2. Indices understands that, or understand this statement as 8 exponent 1 over 3. The cube root of 8 is the same as 8 exponent 1 over 3. Indices can express 8 in terms of 2. That's 2 multiplying itself 3 times. And this 3 here can multiply the exponent 1 over 3. This 3 cancels that. You'll be left with 2 exponent 1, which is 2. So indices is saying that the nth root of any number is the number exponent 1 over n. The nth root of any number is the number exponent 1 over n. Again, let's look at this theorem too. Let's say the nth root of a number with an exponent. Let's do it this way. The nth root of a number a with an exponent of m. Indices will say that this statement here is the same as a so this m will multiply 1 over n, so we have a m over n. That's what indices will say. Another theorem is saying that if you have the nth root of a m, indices will say that a m 1 over n, which is a m over n. So we've seen this. Also, we've seen this, and we've seen the nature of this. That when you have the nth root of a number, all exponent m, is the same as the number exponent m over n, and when you have the nth root of a, is the same as the number exponent 1 over n, and you have the root of a is the same as the number exponent 1 over 2. If you have the nth root of a exponent m is the same as the number exponent m 1 over n. Now with this, with the nth root of a. Let's look at this example. If I have the fourth root of 16, the fourth root of 16 means that 16 raised to the power 1 over 4. So 16 here can be expressed in terms of 2. Say 2 raised to the power 4 will give you 16. And this 4 here can cancel this 4. So the answer is 2. So the fourth root of 16 is 2. You can confirm that from your calculator and see. Now let's look at this last example. 81 exponent 3 over 4. 81 exponent 3 over 4. This thing can be written as 81, let's say, can be written as this: 81 1 over 4 exponent 3. And this thing can be written as the fourth root of 81 exponent 3. And the fourth root of 81 means that what number can multiply itself 4 times to get 81? And the only number that can multiply itself 4 times to get 81 is 3. So you'll be left with 3 exponent 3, and 3 exponent 3 is 27. Now the property 4, I call the ratio of negative powers. And it's saying that the ratio of two numbers with negative index is the reciprocal of the numbers with a positive index. So before we come back to this statement, or before you can understand this statement very well, let's look at this case. Let's look at an instance of, let's say, a negative 2. A negative 2, we saw that this thing can be written as 1 over a exponent 2. Now, what we are trying to say is that, coming back to this statement, a negative 2 is the same as you reciprocating this value here, a here. Let's group this, because we have negative index here. Now every whole number is over 1, so we have a over 1 negative 2. Now when you reciprocate this, the moment you reciprocate, this index changes to positive 2. We are hitting back here. We want to get this answer from what we know previously. Now the square here affects 1, and the square here affects the denominator a. 1 squared is 1, and a squared is a squared. So if you have any number with a negative index, just reciprocate the number, and so that the negative index will tend to positive. So what are we trying to say? If you have a on b with a negative index of k, this thing becomes b over a with a positive index of k. And this k affect this k affect this. That's what we are trying to say. So when you have 2, 3 with an exponent of negative 2, this thing becomes 3 over 2, so that the negative 2 will change to positive 2, and the square affect 3, making 9, the square affect 2, making 4. Again, if we have 1 over 5 with an index of 3, we just reciprocate this. When you reciprocate this, you get 5 over 1. Then this index changes to positive 3. And what do we get? We get 5 cubed over 1 cube. 5 cube is 125. And 1 cube is 1. So the answer is 125. Similarly, you can also solve this problem this way. 1 on 5 exponent negative 3. This 1 on 5 exponent negative 3, the negative 3 affect this one. Or you can, let's say, okay, 1 negative 3, 5 negative 3. Now this thing can be treated like this. Again, this thing here, 1 negative 3 is still 1 negative 3. 5 exponent negative 3 is the same as 1 over 5 cube. 1 exponent negative 3 is the same as 1. Now, because this thing is division from fractions, when you have a division sign, you can reciprocate the one on the right hand side. So we have 5 3 over 1. And 1 times 5 over 3 divided by 1 is the same as 5 exponent 3. And 5 exponent 3 is the same as 1, 2, 5. So you can also solve it this way. If you are not clear with 1 exponent negative 3 giving you 1, 1 exponent negative 3, let's say 1 exponent negative 3 is the same as 1 over 1 raised to the power 3. And 1 raised to the power 3 is 1. And 1 over 1 is 1. That's why I wrote 1 here. That's how it works. Now, another theorem is saying that if I have a exponent negative m over n, a exponent negative m over n. So from what we know, just reciprocate this so that the index here, the negative index will tend to positive index. So a exponent minus m over n becomes 1 over a m over n. And this thing here is the same as, and this thing here is the same as 1 exponent m over n and a exponent m over n. And 1 exponent m over n is still 1. We have a m over n. So with this, let's use some numbers. If I have 2 exponent negative 3 over 5, it's the same as 1 over 2, 3 over 5. The same as 1 over 2 exponent 3 over 5. Also the same as, can I treat this as 1 over the fifth root of 2, or you can keep 3 here. You can keep 3 here and do it like this, or you can say that 1 over the fifth root of 2 into bracket exponent 3. You can also do it like this. So this is acceptable, this one too is acceptable. The next theorem we are going to look at is, let's look at a over b all exponent negative m over n. So from what you know, just reciprocate this and this index will tend to positive. So we have b m over n and a m over n. So if you have 3, 5, and we have negative 1 over 2. So this thing becomes 5 on 3, and this index will tend to positive. That's 1 over 2. So we have 5 exponent half and 3 exponent half. That's root 5 over root 3. Also the same as the square root of 5 over 3. So this is what happens under the 4 properties of indices.